All right, let's just jump right into it. Today, in this explainer, we are unpacking the epic journey of the southwest monsoon. And look, this isn't just some regular seasonal shift. We're talking about a weather system so incredibly immense and powerful that it literally dictates the destiny, the economy, and the daily lives of over 1 billion people. To really grasp the sheer scale and economic weight of this phenomenon, we have to look at how nature's greatest climate engine operates. It is a wildly complex, global system. Think about it. A shift in ocean water off the coast of South America can literally mean the difference between a bumper crop and absolute famine for a farmer in India.
To make sense of it all, we're going to break this massive global event down into 5 parts: the monsoon's arrival, the climate engine driving it, the 2 wind branches, global influencers, and finally, breaks and the retreat. Let's get right into it.
Part 1. The monsoon's arrival. And actually, a quick fun fact for you, the word monsoon itself is believed to come from Monsoon, which is the Arabic word for season.
So, what we're looking at is a massive seasonal shift. In the summer, these moisture-heavy winds barrel in from the ocean directly toward the land. But then, when winter rolls around, the whole thing just flips, and the winds blow from the cold landmass back out to the sea.
And the contrast between these 2 phases is honestly night and day. The northeast winter winds blowing from the land to the sea are mostly bone dry, though they do bring a bit of rain to places like Tamil Nadu. But the southwest summer winds, they arrive absolutely packed with moisture from the Indian Ocean. This is what brings those heavy summer rains between June and September, providing the crucial water needed for massive agricultural irrigation and, of course, generating a massive chunk of India's hydroelectricity.
Moving on to part 2, the climate engine. So, what actually flips the switch on this colossal weather machine every single summer? Why does the wind suddenly decide to rush toward the land?
Well, the crucial point here is intense differential heating. As the sun shifts north in June, parking itself right over the Tropic of Cancer, it bakes the Indian landmass incredibly fast. This intense heat pulls a low-pressure zone, the Intertropical Convergence Zone, or the monsoon trough, right up to the Indo-Gangetic Plain. This creates a giant thermal vacuum. The southeast trade winds from the southern hemisphere get violently sucked across the equator to fill that vacuum. And as they cross, the Earth's rotation, via the Coriolis force, bends them into that signature southwest direction.
But it's not just happening on the ground. There's crazy drama high up in the atmosphere, too. The massive Tibetan Plateau heats up like a frying pan, creating a high-pressure cell way above it. This shoves a tropical easterly jet stream south, thrusting it down into the Indian Ocean over a spot called the Mascarene High. So you've got this high-pressure push from above and a low-pressure pull over India. Together, they act like a giant atmospheric pump, triggering what meteorologists call the sudden burst or onset of the monsoon. Which brings us to part 3, the 2 wind branches. Because once this massive wall of moisture actually hits the Indian subcontinent, the physical geography of the land forces it to split.
But before the split, just look at the relentless schedule this thing keeps. It usually hits the Andaman and Nicobar Islands by mid-May, strikes the Kerala coast right around June 1st, and then just bulldozes its way north, blanketing the entire country by mid-July.
Right as it makes landfall, the southern tip of the Indian Peninsula acts like a giant wedge. It literally slices this incoming oceanic wind into 2 totally distinct pathways, the Arabian Sea branch and the Bay of Bengal branch.
Let's tackle the Arabian Sea branch first. This one is an absolute beast. It's roughly 3 times stronger than the other branch. It violently crashes into the towering Western Ghats, forcing the air up, cooling it rapidly, and dumping extreme rainfall. We're talking 250 to 400 centimeters just on the windward side. Once it finally crosses the mountains, it dries out, leaving the eastern side in a total rain shadow. Meanwhile, other sub-branches funnel deep into central India along the Narmada and Tapi rivers, pushing all the way up to the Saurashtra Peninsula and Kutch.
And we really can't forget the real-world stakes here. The raw, terrifying power of this Arabian Sea branch was on full display during the devastating 2018 Kerala floods. It was a very grim reminder of just how vulnerable these coastal regions are to extreme rainfall.
Meanwhile, the Bay of Bengal branch takes a totally different route. It sweeps east toward Myanmar, but it smacks right into the Arakan Hills. That mountain range acts like a giant wall, deflecting a huge chunk of the wind right back into West Bengal and Bangladesh. It pivots west along the Ganga Plains, eventually meeting up with the Arabian Sea branch. But here's the wild part. Another section of it surges straight up the Brahmaputra Valley, hammering the Garo and Khasi Hills. The geography there funnels the clouds so perfectly that a town called Monsoon in Meghalaya gets the highest average annual rainfall on planet Earth.
Part 4. Global Climate Influencers. Now, you might think the monsoon is just a local Indian event, but it's actually locked in a massive global tug-of-war with ocean forces thousands of miles away.
A huge player here is ENSO, the El Niño Southern Oscillation. During its warm phase, known as El Niño, surface waters off the coast of Peru in South America get unusually warm. This seemingly random, distant event totally messes with the Pacific trade winds. The normal flow reverses, basically stealing the moisture-laden winds away from India. For India, an El Niño year often spells disrupted rainfall, severe droughts, and a massive threat to the food supply.
On the flip side, we have La Niña, the cold phase. During La Niña, the water in the eastern Pacific gets way colder than normal, building up intense high pressure there. This basically turbocharges the low-pressure system over Asia. For the Indian monsoon, La Niña is a fantastic ally. It amplifies the winds and brings abundant, beneficial rains, completely flipping the script on potential droughts.
But closer to home, there's another major player, the Indian Ocean Dipole, sometimes called the Indian Nino. This is all about the temperature difference between the Western Arabian Sea and the Eastern Indian Ocean. When it's in a positive phase, the waters in the Western Arabian Sea are unusually warm. That warm water causes hot air to rise, increased convection, which significantly boosts the monsoon and ensures a really healthy rainfall season.
Finally, Part 5. Breaks and the Retreat. Because all good things must come to an end, right? But the monsoon's exit is rarely a smooth process.
Even right in the middle of the season, the system takes breathers. Meteorologists call these breaks. These are completely dry, rainless spells that can drag on for weeks. Up north, they happen if the monsoon trough shifts. Down on the west coast, breaks hit if the winds suddenly start blowing parallel to the shoreline instead of crashing into it. These dry spells are incredibly stressful, leaving farmers just staring at the sky, waiting for the rain to come back.
Then, as we hit October and November, the sun starts heading back south. That massive low-pressure engine over northern India starts to sputter out and gets replaced by high pressure. By early October, the monsoon starts its retreat. The skies clear up and temperatures spike, but because the ground is still completely soaked, the humidity goes off the charts. It creates this incredibly sticky, oppressive weather known as October heat. By November, that transition is fully complete and dry winter conditions finally take over.
Which brings us to a pretty massive closing thought. We've just seen how perfectly balanced this whole system is, entirely driven by temperature differentials and ocean currents from across the globe. But as we watch ocean temperatures fluctuate wildly, and things like El Niño and La Niña become way more unpredictable, it really makes you wonder, how is the delicate balance of this life-sustaining monsoon going to evolve? Will it continue to reliably feed 1 billion people, or is this ancient, epic journey going to fundamentally change? Thanks for tuning into this explainer today, and keep your eyes on the fascinating systems that shape our world.